So basically, let's move ahead and look at these examples. So basically, this is one of the application examples of calculus 2. Let me say integration with the using initial conditions. So let's look at it. This question it's from one of the books, Bass Calculus. Yes, so if you want more questions, you can just refer to it and then check from there. So basically, let's look at it. Physical science, height of a thrown object, that's where it's coming from. A rock is thrown directly upward with an initial velocity of what? The initial velocity of what? 50 feet per second. So that's our initial velocity. Initial velocity is what? 50 feet per second. And then from an initial height of 10 seconds. So if let's say our initial velocity is what? V1, which is equal to what? 50 feet per second. Let me write it way. 50 feet per second. And then our initial height h is equal to 10 feet. The velocity of this rock is molded by the function v of t equal to negative 32t plus 50, where t is in seconds, right? T is in seconds. V is also in feet per second, and t equal to 0 represent, that's t equal to 0 represent the moment the rock is released. So the moment that the rock is released, that's what we are going to have. It's happened at t is equal to 0. So what they mean is that the A is telling us that determine a distance function h as a function of t. In this case, distance is the same as the height. Be sure to consider the fact that at t equals to 0, the rock is 10 feet. So this is what it means. So determine a distance function. So take note of this. Take note of this. From distance to velocity, we differentiate, right? We differentiate, right? And then from velocity to acceleration 2, we differentiate, right? We differentiate. But from acceleration to velocity, we actually integrate. From velocity to distance, we also what? Integrate. So take note of this. And now we have our function in velocity, and they want us to find a distance function of which from velocity to distance we need to integrate. So this is one of the applications of what? Integration. So based on that, what we can do is that we write our velocity function that v of t equal to negative 32t plus 50. And then when we find the integration of both sides, when we integrate velocity, you get what? The distance, which is the height, and it should be equal to, now we need to integrate this. So integrating this, we are going to get negative 32t squared over 2 plus what? 50t. And don't forget plus your c. So now we have h equal to, this will give us negative 16t squared plus what? 50t plus c, right? So this is what we have. But remember that they said at t equal to 0. When at t equal to 0, let's read the question again. Be sure to consider the fact that at t equal to 0, the rock is at 10 feet above. So when there's no time, when the time has not yet started, the rock was initially at the height of what? 10 feet. When the thing has not started, the rock was initially at the height of what? 10 feet. So therefore, at t equal to what? 0, h was equal to what? 10 feet. So in that way, this becomes your initial conditions. The t equal to 0 and then h equal to what? 10 becomes your initial conditions, which is going to help you to find the value of what? C over here. And therefore, getting there, we are going to get 10 equal to negative 16 and then t is 0 squared plus 50 and then 0 plus c. And therefore, 10 equal to, here will give us 0 and here will give us 0 and then plus c. And therefore, 10 equal to what? C. So therefore, our value of c is 10. So we can go and plug it back. H equal to what? Negative what? 16 t squared and then plus 50t plus 50t and then plus what? 10. So this is our distance function. This is our what? Distance function. This is our distance function. So let's move to the next question. The next question is what? The next question is what? Determine the height and the velocity of the rock after 3 seconds. So we say we should determine the height and the velocity of the rock. Let me remove this one from there. We'll be solving this, right? So let's move to the second question. So they said determine the height and the velocity of the rock after 3 seconds. So now we have our height here, and then our height is h equal to negative 16t squared plus 50t plus 10. And then they have given us the point that we should determine after 3 seconds. That means our t equal to what? 3 seconds. So for t equal to 3 seconds, our height is equal to h is equal to negative 16 multiplied by 3 squared plus 50 times 3 plus 10. So in this way, h equal to 3 squared will give us what? That is what you need to do. 3 squared will give us 3 times 3 was 9, right? So negative 16 times what? 9, right? And then plus 50 times 3, which is 150 here, and then plus 10. So at the end of the day, we are going to get our h equal to what? 16 feet. That's h of 3, which is equal to what? H of 3. And that is what? H of what? T. So based on this, we are going to also find the velocity. You know that our velocity was equal to, when we look at the function, our velocity was equal to negative 32t plus 50, negative 32t plus 50. And therefore, at t equal to 3, which is v of t equal to v of 3 equal to negative 32 times 3 plus what? 50. And therefore, the velocity for this one is giving us what? Negative 40.6 feet per second. So don't forget that with this 16 feet, you bring the feet because the distance, and this one negative 46 feet per second. Thus, the rock is, when you explain, or the smaller interpretation of this one is that the rock is 16 feet above the ground at 3 seconds. but the negative velocity indicate that it is moving downwards. It is moving downwards, right? It is moving downwards. Thank you for watching and see you in my next video.